All right. So this is we are going to continue with our um, polynomial series, whereby in the last class we talked about the definitions of polynomials and um, the general terms of polynomials. All right. So in this class we are just going to be reviewing quadratic equations, that is polynomials of degree 2, and how you can solve some other new or some other different things about what your quadratic equations. All right. So now, but before we start, don't forget to subscribe to this channel, and also like and place comments and questions where needed or where necessary. All right. So now we are looking at all right. So now, looking at this now, let's look at this. So quadratic equation reveals. Now when you consider a quadratic equation, when you have what degree 2, that's ax squared plus bx plus c equals to 0, that's polynomial degree 2. you can use this to get our quadratic formula like this. I get it, that which you can use to solve problems. In the last class we said that there are different ways you can use to solve quadratic equations. You can use factorization method. This is completing the square, which I use to derive formula method. Also, you can also use formula. You can also use formula method to solve. You can also use graphical method to solve. Idea now. All right. So let's quickly just brush through this. All right. We have ax squared plus bx plus c equals to 0. First step is what? Ensure that the coefficient of x squared is what? 1. Now the coefficient of x squared is a. So for it to ensure that it's 1, we divide through by what? A. Now. So when you divide through by a, you have x squared plus bx over a plus c over a equals to 0. Next step is what? Bring your what? C over a to the other side of the equation. So that's your constant term to the other side of the equator. So when we bring our constant term to the other side of the equator, we have this idea. Now the next part is the tricky part. Now for us to use completing the square method, then we have to introduce some things, whereby that is, now we want to complete the square. Now how do you complete the square? That is, you pick the value of your the coefficient of your x, that is the coefficient of your x variable, maybe the coefficient of the one that is having raised to power 1 now. So the coefficient, you multiply by half and you raise it to the power of 2, and then you add it to both sides now. That is, you have x squared plus bx over a plus, you pick this one, that's 1 over 2 times the coefficient of x, whether it is 2, whether it's 100, coefficient of x, that's 1 over 2 times coefficient of x, close bracket, square, add it to this side, and this one too, come and add it to this side again. Now can you see now? So from here we have this times this will give us b over 2a square, this one to give us b over 2a square. Now you have a square, you have a square here, bring it together and put it in a bracket. Now, so this is x and this is b over 2a, put everything in bracket. This equals to minus c over a, open this bracket, b square over 4a square. So from here now we can find the LCM. LCM here is 4a square. I have this now. So from here we can bring the square to this side, it becomes plus or minus square root of this. And what's the square root of this one? Square root of this one is what? 2a. The square root of 4a square is 2a. That's why the root is not covering this now. And we bring this to this side, you have minus b over 2a. Now, so we have this. So when you find the LCM of this, LCM is what? 2a. 2a into a 1 times this, you have this. 2 into a 1 times this, you have this now. So which brings us to our quadratic formula. Are we there? All right. So now that's how we got our quadratic, or how we are to get our quadratic formula, and we can use those formulas to solve problems on quadratic equations, that is polynomial of degree 2. All right. So now we have the next subtopic we are going to look at here is root of quadratic equation. That is the nature of the root of quadratic equation. Now in most cases you discover that there are some quadratic equation whereby maybe when you use any of the method, maybe factorization method or computing the square method or formula method or graphical method, any method you use, there are sometimes whereby you get the two roots, that is your solutions, the two roots no, for quadratic equation we get two roots. And for those that are not really familiar with quadratic equation, I would suggest that you have to go and review it so as to have more background knowledge of what we are talking about. All right, so now you know that there are some times whereby you can have two roots. Sorry, you can have two roots whereby they are equal. Sometimes you can get an answer whereby you have x equals to 2 and x equals to 2 as your answer. Sometimes you can get x equals to 2 and x equals to minus 3. I don't know. Sometimes you can get x equals to 2i plus 1. Do you get it now? That is, the nature of root of quadratic equation is such that we can have roots whereby they are what? Imaginary roots. I don't know. They can have roots whereby they are real and unequal. That is, maybe there you get x equals to 2 and x equals to 3. You get it now? And you can have roots whereby you have real and equal root whereby you have x equals to x equals to 2 now. So all those things are some of the natures of the roots that we have. And when you read through what we have here, the position of the curve relative to the x-axis depend on the nature of the root of the quadratic equation. Thus, the nature of the root is determined by the discriminant b squared minus 4ac. That is, this your value of b squared minus 4ac that you can find in your quadratic formula. If you test it, that is, if you have an equation whereby this is your b, this is your a, this is your c, if you test it using this, that is, this formula you have here, and you put the value of your b, you put the value of your a, and put the value of your c, and your answer is less than 0, then you should know that what the roots you get for that quadratic equation will be imaginary. Imaginary means whereby you're having a form of a complex number, and that is a little bit more advanced. Most of when you are using calculator, you discover that you get maybe like 2i as your answer, or 3 plus 2i, or 3 plus 5i identical as your answer. You get an imaginary root. Also when you test it, that is the equation you are given, and you test it and the value of your answer is greater than 0, just take note that your root should be a real root and an unequal root. That is, you can get something like 2,3 as your answer, or 5,1, or minus 1,1. How you do now? Do you get it now? So as your value. So this is just a way of testing whether your root or your final answer you get will be maybe equal, maybe unequal, maybe imaginary. You get it now? So, and when it is equal to 0, you should know that what you definitely get an equal root. Are we together now? All right, so now let's move to another subtopic. All right, so let's quickly look at this. Now we have what we call sum of roots and product of root. You must have heard of this before, whereby you can sum your root together, we can get the product of the root. So why are we doing all this sum of root and product of root? The ideology will be gotten from your quadratic equation. By the time we continue further, you discover that some of this sum of root and this product of root, we can use it to get back our quadratic equation. In a case whereby you are given the roots, that is your solutions, your final solution, and they ask you to derive the equation, then we can use this sum of root and product of root to get this equation back. So that is one of the major reasons why we sometimes deal with sum of root and also product of root. How we together now? All right, so now we have for this equation, this where a is not equal to 0, that means a must not be equal to 0 for this to be quadratic. Are you there now? As alpha and beta as roots, so that means alpha and beta are the roots of this equation. From formula method, your final solution should be what? This, that is, from completing the square, our final solution to give us what? Minus b plus or minus root of b squared minus 4ac over 3. That's what we are supposed to get. And now we are saying that alpha and beta are our roots. That is, the two answer you get when solving a quadratic equation is alpha and what is beta. So if alpha and beta are the root, that means alpha is equal to positive of this and beta is equal to negative. Those are the two roots you get. When you want to solve quadratic equation, use formula method, you are going to divide it. That is, your x equals to this or your x equals to this, and you get your final answers, which are the roots where we have here, whereby we have what? Alpha and beta. All right, so now what is alpha plus beta? That is sum of that this plus this one plus this one. First thing first, find the LCM. When you find the LCM, this one, this you have this back, and this 2a divided by 2, you have 1 times this, you have this idea now. So this one cancel this, and then you have minus b give us minus 2b over what 2a, and this cancel this. Eventually you have alpha plus beta equals to what? Minus b over a. Now we also have product of, now we have what we call product of roots. That is when you have what? Alpha beta idea now. That is, you have your first solution and your second solution, which is what we have here. Now alpha beta, what will you get for alpha beta? Now for alpha beta, we know that what you have this times this, that's product of roots. That is, this one times this one give us 4a square, abi? Now for this one times one, normally you have to do this times this times this minus times this times this, and you get your answer. You cannot simplify. But another short way of doing it is that this one is looking like difference of two square. That is, you have positive of, you have negative of the same values. I don't know, a square minus b square give us a plus b, a minus b. That is, this one should be minus b square, which give me minus, which will give me b square, and then this one square, which will give me on this square, and that square will cancel the square. That's why you have this. But if you don't understand this, just multiply one after the other and simplify. You will get back to this idea now. All right, so from here now, if I open the bracket, this will be negative and this will be positive, and this will cancel this idea now. So we have what? 4ac left, and we have over what? 4a square. So 4a will cancel 4a. All we have here is c over a as your alpha beta. All right, so in general now we know that what alpha beta is. All right, in general now we know that alpha plus beta is minus b over a, and alpha beta is c. All right, so we know that what alpha plus beta is minus b over a, and alpha beta is c over a. So now you see that we have gotten it now from this general formula. You have a square plus b square plus c equals to 0. If I divide through by a, I have this. Can you see that this one now is looking like what? Sum of the roots. That is, when you sum the root together, you get minus b over a. That means you get the negative of the coefficient of x, and when you multiply the roots together, you get what? The constant term of what? The quadratic equation idea that you use to get that root idea. So you see that there's a relationship between the quadratic equation and the roots of that quadratic equation when we are dealing with what? The sum of the roots and the product of the roots. So the sum of the root is related to the, you can use to get the quadratic equation, and the product of the root you can also use to get the quadratic equation. That is, if b over a, we can replace it with what? Minus alpha beta, because alpha plus beta is minus b over a. So if alpha plus beta here is minus b over a, I know minus and minus give me plus, which will give me this one back. I don't know. We have this. All right. So and alpha beta is c over a, which is what? Alpha beta. So you see that when you add the root together and you multiply by negative, you get what? The coefficient of your x, and when you multiply the roots together, you get what? The constant term. Are we together? All right, so now let's quickly formulate an equation when you are given the roots, so you can try other examples on your own. All right, so formulation of equation when the roots are known, and that is, if 1 over 2 and 3 over 2 are the roots of an equation, form the equation. Now you are given the roots, you have to form the equation. You can either use this format of alpha plus beta and alpha beta, or you can decide to start from scratch and then build from down to up, and that is one of the ones that we have been familiar with. All right, now let's use this method. We know that alpha, this is at the root, that means this is alpha and this is beta. Now alpha plus beta is this plus this, which will give me 2, and this implies we have b over a. This is your b over a. Now alpha beta is what? This times this, that is 3 over 4. Right, now to formulate our equation, simple. So we know that we start with x squared minus alpha plus beta x, because this one is the value of what? Minus b over a, which will give us plus b over a. That's minus alpha plus beta is what? 2x idena, plus alpha beta is what? 3 over 4. So we have this equation. Now for us to make it more final, we can multiply through by 4 in order for us to remove this fraction. So when you multiply through by 4, you have 4, you have 8, and you have 3 equals to 7. Can you see that we are able to formulate this equation using what? Sum of roots and also product of roots. I get it now. So this is where we are going to stop from today. All right, so in the next class we are going to be looking at more ways you can use your sum of the roots and your product of roots when dealing with polynomials. And then in the future videos we are going to look at other addition of polynomials, subtraction, divisions, and the likes. I don't know, and different other few theorems. I don't know. All right, so don't forget to like and subscribe, and also share this video to those who need them. So see you in the next class.